Hey kiddos, so today we're going to be going over visual representations of rational numbers. Please feel free to pause, rewind, fast forward, and do whatever you need to do at your own pace. So, rational numbers is where a fraction, where it could be a fraction and your denominator cannot equal 0. So a rational number is any number that can be written as a fraction. We're going to use A and B to represent our fraction, with the denominator B not equal to 0. So here's the real number system, okay? I know it looks like a lot, but it's not. Just breathe with me, okay? So for the real number system, it all breaks down to different subsets. So the smallest part of the subset of the real number system will be called natural numbers or counting numbers. Those numbers will be the numbers that you can count from 1 all the way into infinity, okay? So no negatives in here, only positives, and 0 is not included. For whole numbers are the exact same thing as natural numbers, but they do include the number 0, as you can see right here. We are going to include the number 0. Integers are whole numbers that include negatives. So whole numbers don't include negatives, natural numbers don't include negatives, but integers do include negatives. So you'll have -2, -1, 0, 1, 2, etc., etc., okay? Remember that none of these, from natural, whole, or integers, none of these have a decimal or fraction in them, okay? You only get decimals and fractions when you get to your rational numbers. So numbers in the form of A over B, where B is not equal to 0, is a rational number. So let's look at some examples of rational numbers. So we have, like we said, the natural numbers, the counting numbers, 1, 2, and 3. Whole numbers, including natural numbers, and 0. So 0, 1, 2, 3. Integers, whole numbers and their opposites, meaning positive and negative. -3, -2, -1, 0, 1, 2, and 3. Fractions, 3 over 4, which is same thing as 0.75, and that will be rational, okay? It can be a decimal, but the decimal has to repeat. If it just is not a repeating decimal, that is no longer a rational number, and it has to be able to make a fraction. If it cannot make a fraction, then it's not a rational number. So see how these decimals are repeating? They have a typical pattern. So those are rational numbers. So terminating decimals, meaning that the decimal stops like this. Those are also rational numbers. And then, of course, your perfect squares. Your perfect squares, like the square root of 25, the square root of 4, the square root of 36, those perfect squares are rational numbers. So for rational number relationships, it says to create a visual representation that describes the relationships between types of rational numbers. Use the words and numbers below by placing them in the diagram, in the appropriate places on the diagram. So we're going to use this diagram. We're going to use these vocabulary words, and we're going to use these different integers. These different numbers, and we're going to place them where they belong, okay? We'll do that together. So I have my thing right here, and I'm just going to go ahead and put that out for you guys. I'm not going to waste your time with it because you can, like I said, you can pause, rewind, do whatever you need to do. And yeah. This is real number relationships. This is where everything would go in